Welcome to our graduate seminar. Today's speaker is Dr. Logan Mitchell from our department. Probably most of you know Logan very well, but let me give you, nevertheless, a brief introduction. Logan got his PhD at Oregon State University, probably in 2013, I guess. And where he did work on analyzing greenhouse gases in ice cores from Greenland and West Antarctica. And that resulted in a couple of really high-profile papers, which not only Logan co-authored, but also authored, like papers in Nature Science, Nature Geoscience. So this was really nice to see that. And then in 2013, Logan started to work here in our department. He joined the group by John Lynn as a postdoc, and he established essentially the Utah Tracks CO2 measurement system. I assume that's explaining it well enough, right? I don't know it so well. And in 2018, Logan was appointed to become assistant research professor in our department. Yeah, so maybe also like characterizing general research interests of Logan is, of course, air quality, but maybe also climate change in general. And it seems to me that Logan is also more on the observational side of things, if that is correct. Okay, so with this, I hand over to Logan and yes, share your screen, please.
All right, thank you. Yeah, so this, I'm definitely on the more observational side of things. And actually as part of the way that this current project kind of started is as part of the Aquarius project. I was looking around. I wanted to write an introduction about, when people started caring about air quality in Utah, and I looked around for something. I just couldn't find anything that was there's little bits. I found a few things about a short time period here or a short time period there, but there was no kind of comprehensive history of Utah's of air quality in Utah. So that's kind of why this is the untold histories, because I've been doing a lot of digging, and it's amazing what I've found. It's a really rich history. It's really fascinating, and there's a lot of parallels to today. And I think having a better understanding of our history can better inform kind of current discussions and going on into the future. So of course, as we all know, that we have bad air quality in the summer and the winter, caused by our emissions, our topography, meteorology, and chemistry. But why do we really care? It's really because of these health impacts. This was a summary of health impact studies for different health systems throughout the body that I helped with. It was published in 2020 and listed. You don't need to read all of the things that can go wrong that can cause health impacts from air quality, but just to note, the ones that are bolded in red, those are actually studies that have been done in Utah, and it kind of illustrates kind of the contribution that Utah research has made to the health impact side of air quality. And this is review for all of us here, but this is one of the surveys that really stuck out to me. Is 2014. The Envision Utah asked about priorities for Utah, and air quality ranks up in the number 3 in this survey. And they asked about performance on priorities, and it was dead last. And so this really illustrates this dynamic of air quality is very important, but a lot of people feel like not enough is being done to address it. Here's a couple other reports from 2016 and 2019. Air quality consistently ranks in the top top 3 issues of folks who live in Utah. But to really understand the history of air quality, you have to think about how our energy sources have changed over time. So this is just from the EIA. This is just energy consumption for the entire United States, but it's a reasonable proxy for energy consumption in Utah, at least looking at how it has changed over time. So when the pioneers first arrived in 1847, energy use was really dominated by wood burning and a little bit of coal, but mostly when they first arrived, it was wood burning. And before I go on, I'll just note that there has been some kind of urban mythology about whether or not Native Americans, really focused on air quality or talked about air quality. I haven't been able to find any oral histories of that yet, but that's kind of an open area of research that there's still many little tangents in this history that need to get further explored. But this is one of the first kind of more prominent discussions of air quality, and it's actually from Brigham Young in 1860. And in the Desert News back then, they just, this is just a speech that he gave, and they would just print his remarks. That was what the newspaper was. But it says, what constitutes health, wealth, joy, and peace? In the first place, good pure air is the greatest sustainer of animal life. Other elements, we can dispense with for a time, but good pure air is essential for every moment. And the context of what he was talking about is having good, well-ventilated homes, especially rooms that where you sleep. And that's because, in pioneer days, if you didn't have a well-ventilated chimney, you'd trap all of those emissions in your house, and people did die from that, and so it was a very serious issue. So the kind of practical advice from Brigham Young about the importance of air quality and indoor air quality. Another side note is it's interesting that recently in the past few years there's a lot more focus on indoor air quality in terms of natural gas stoves and things like that, as well as pollution permeating through the house into the inside of the house. And so it seems like we've kind of come full circle now from Brigham Young in 1860, and now we're coming back to indoor air quality is an important issue to focus on. But air quality really started to become an important public issue in the 1880s. And this is an editorial. It's the nuisance of smoke, and there's some really key parts of this that I wanted to highlight. And this is just an excerpt from that editorial, and it says, Salt Lake's beginning to suffer from some degree of the smoke nuisance. So back then they didn't call it air pollution, they called it smoke, because if you see something coming out of a chimney, that's smoke. So if you're getting excess smoke, that's what they called air pollution. And judging from the dense clouds that arise in the evening in the central part of the city, we're of the opinion that the time is not far distant when some municipal regulation will have to be adopted and enforced here, as in other places, to address it. But then they said, wouldn't it be just as well if the businesses that require coal in large quantities look around for some remedy for the excessive smoke and of their own volition, and thus avoid the necessity of declaring their works a public nuisance? We think so, and throw out the suggestion in kindness. So even back then, there was a preference for industry, private businesses, to figure out how to address their own emissions without without resorting to regulations. It's interesting to see that common thread through this whole timeline. Nevertheless, things continued to get worse, and in 1891, Salt Lake City passed its first air quality ordinance. That's this picture is the actual ordinance. 1891 is 5 years before Utah actually became a state, joined the Union. So that means that literally air quality regulations have been in place for the entire history of the state of Utah. And just thinking about the scale of that has been really helpful for me to understand kind of the broad scale of this problem. It's not a recent problem, and it doesn't have easy solutions. And really Utahns have been working on it for the entire history of the state. The ordinance that was passed, it was a misdemeanor. So if you were letting excessive smoke go out of your chimney, it was a misdemeanor, and they would charge you $5 to $50 per day, which in today's dollars is about $150 to $1,500. And the focus was really on installing what they called smoke consumers, which are emission control devices. And in those days, it was really focused on, making sure your boiler was more efficiently burning, so your emissions were a lot lower. The first discussion that I've found that relates to meteorology is in 1893, and they were really thinking about where to put factories as the city is growing. Where do you want to put the factories? And so there's just a bunch of things that I think are great in this article. And so they note that there's an decided objection to locating any factory at the mouths of the canyons on account of these being the ventilators of the city. There'd be as much use in using a chimney as a fresh air ventilator at a house. And then they said, those who are conversant with the air currents, which I guess that's the terminology for meteorologists back in the 1890s, say that during the heat of the day, the currents from the canyons are very perceptible, and if a factory were located there, the smoke would blow over the entire city. So they didn't quite get the valley, the canyon flows in the right direction, but they're at least aware that there are canyon flows. And then they thought, smoke never crosses a river. It's obviously not correct, but there can be some kind of thermal barrier next to rivers, and so the place to locate all factories is west of the Jordan River. And so that's what informed a lot of where the industrial part of the town is actually related to air quality. But this last part is really interesting to me because just in terms of how they were thinking about air quality in the 1890s. And its factors that blacken the city with smoke can be as much of a detriment as they are an advantage. For Salt Lake has as much to expect from the increase she'll receive from persons who select it as their residence on account of its pure air and cleanliness as it has to gain from factories. So even back then, they're trying to balance the economic development and environmental stewardship, and in recognizing that there's tension there, and that as the city is developing, there needs to be some sort of balance and trying to find good solutions. So, a lot of the factories that got built were west of the Jordan. That's where in current times, that's where the kind of the Rose Park neighborhood is, and that's where all of the refineries are, and some power plants as well. And that's where we see a lot of environmental justice challenges today. And it really points to this long tail of development decisions that, these are urban development decisions that happened in the 1890s that, are having consequences that reverberate to today over 100 years later. And so just it points to the importance of urban development and urban planning. It also probably had, it probably also factored into historic redlining. That's where folks would section off parts of the city and force racial minorities to only allow them to move and buy land and live in those parts of the cities. And so you can see that kind of on the east part of the city, you're getting kind of the best and desirable parts of the city, but then over on the west side are listed as hazardous. And so it's interesting to see air quality definitely played a factor in determining that those parts of the city were hazardous, and that plays a factor into where different people were allowed to live. And it also, again, has a long tail, and that's kind of determines the current mix of neighborhoods that we see today. This is the census data for different races, and you can see, the West Side has a lot higher population of Hispanic folks. Going back to the history, though, in the around the turn of the century, Salt Lake was a very important area for smelting of ores. But at the time, there were no pollution controls. So the smelters just emitted all kinds of extremely toxic emissions: lead, arsenic, sulfur dioxide, lots of stuff. And what started to happen was that the crop fields adjacent to the smelters started to just die. They were just being killed off by these toxic fumes. And so that set up this big conflict between the smelters and the farmers. And eventually it went to federal court. The bunch of farmers banded together and sued the smelters, and they ended up winning in federal court. And the decision was that the farmers had a right to be able to grow their crops, and they had a right to have not have their crops be killed by pollution. And this eventually forced some of the smelters to leave the Salt Lake Valley. Some of them moved to Tooele and other places. But lawsuits followed them wherever they moved, and eventually, slowly pollution controls were developed. This is a political cartoon from around that time, and you can see here's the smelter here. It's about to move. And one of the things that the smelters, the smelter owners were doing is they actually accused the farmers of actually being bad at farming. And instead, since they're bad farmers, the smelters were accusing the farmers of smoke farming. So just buying land next to a smelter, not even trying to farm it, but then just suing the smelter as their source of income. And so here's this farmer saying, "Say, Brother Joseph, do I have to farm my farm now?" And it's since the Mormon farmer can no longer farm the smelters, he asked counsel from the authorities. So this is a big conflict, but it's one of the side tangents that came out of it, is that the smelters actually ended up funding a bunch of research into farming practices because they wanted to prove that the farmers were actually not following best practices. So, they funded studies to look at how much water to apply to crops, how much sunlight they needed, how much fertilizer they needed, those sorts of things. And this is around the time when there was a lot of innovation happening in farming science. And so this is another thread that would be really interesting to follow up on, to see if kind of the air quality conflicts in Utah played any role in kind of the national and global advances in farming capabilities at that time. Moving on, so in the early 1900s, that's really when energy became dominated by coal combustion, especially in cities. People were heating homes with it, and all the factories were running on coal. And in 1912, there are articles in the newspapers throughout this time period. Air quality was a really consistent topic. But 1912, I found this. There was a 6-part series in the Salt Lake Telegram. And this is the second part of the series. It's the economic problem, and it just really struck me the kind of things that they were thinking about. Millions of dollars go up in smoke, and it's a lot of this air pollution is from incomplete combustion. And so the next title is "Annual Waste in Fuel in America Would Build Battleships." And And so they're like thinking about the economic waste and the, being good stewards of their resource. And, back then there was a concern about actually running out of coal because we didn't really have a good understanding of how much was available and how much was economically feasible to mine. But they also understood that the influence on health was most detrimental. And kind of this last thing, the whole system of power conversion ultimately may be changed. And this is really fascinating to me because, I mean, over time, our power system has evolved, but, we're now at a point where this is finally starting to come to fruition. We're starting to electrify our whole economy, and that will happen over the next 1 or 2 decades. And it's only like 120 years later. And it's really interesting to me that the national smoke bill represents millions of dollars of economic waste to the public at large, and the health of a community alone might justify its abatement. And also, smoky cities are cities with high death rates from all bronchial and pulmonary diseases. So there was enough science and epidemiology going on, even in 1912, to understand the health impacts of air quality. They basically had all the pieces to understand the challenge of air quality. They understood the damage to markets and to health. They understood these were negative externalities. They understood that they needed to have energy efficiency, but what they didn't have was access to alternative fuels, something that was cleaner burning. And so, that's what they had to work with. And there's all sorts of impacts on the city. People often wonder about tourism. We talk about tourism being impacted by poor air quality now, especially as people come in to go skiing in Salt Lake. That was a factor back in 1912. Smoke clouds greet tourists in Salt Lake. View of the city is impossible. Visitors are unable to see the Walker Building from the top of Hotel Utah, according to manager of the hostelry. So these are 2 buildings in downtown that were very close to it. You just couldn't see them because the pollution was so dense. And this generated a lot of activism. There were, especially in the 19-teens, women-led groups that organized around air quality issues and really tried to make a difference. They collected data on best practices from other cities around the country and the world. They made information packets and leaflets and passed them out about energy efficiency, how to run your boiler more efficiently. They passed a whole bunch of ordinance across Utah. And, the headlines from this period are really interesting. There's 50 prominent women representing the Ladies Literary Club and other clubs were present to urge passage of an ordinance. At the conclusion of the meeting, which waxed exceedingly warm at times, the measure was referred back to the committee. And so, these were some passionate folks, and there's just story after story in this era of all of this work, all of this activism, and there's a lot of people really working on it. In 1914, the Utah legislature created the metallurgical department at the University of Utah, and this is obviously of importance to us here in our department because at least when I started here, I always thought it was kind of strange that atmospheric sciences was in the same college as metallurgical, metallurgy and mineralogy, but really it comes kind of a unifying theme is actually air quality, because they formed this department and the very first task that was assigned was to work with the National Bureau of Mines and find a better fuel, low-grade coal, that would be foolproof when you burned it and not create as much air pollution, burn more efficiently and didn't have as much incomplete combustion. So really, air quality is at the very founding root of our of this college. And so yeah, it's metallurgists to attack Zion smoke, and these headlines are just, I don't know, I find it really fascinating. University takes up city smoke problem. So this is in the mid-19-teens that this was happening. This establishment of the department and that collaboration with the Federal Bureau of Mines ultimately led to one of the first major studies in the country, air quality studies occurring in Salt Lake City. Salt Lake City was chosen because it's a mid-sized city with a persistent air quality problem, and it's a pretty impressive study that they did. They looked at the fuel quality analysis. They created the first emission inventory, looked at different sectors. They did some air quality monitoring. They did a very basic meteorological study, just looking at wind speed and direction sorts of things. And they looked at some health and environmental impacts, and they recommended a bunch of ordinances and passed a bunch of them. And this is just from one of the reports that I thought it was interesting, and just interesting how they're thinking about and talking about this project. And it's like, and it says, when an industrial community realizes that keeping the air clean is a project of similar magnitude to keeping the streets clean and providing clean water, removing waste, and guarding the moral atmosphere, then we may have some hope of success for smoke abatement. And it's like, when it becomes a really big issue, when the city wants to take it seriously, there is some hope. But you have to have continuous, never-ceasing effort to clean up a smoky city. A few months of relaxation and years of effort are canceled. Success only comes after long, continued, highly skillful effort. And that's where a lot of research has been really important. And so it's just interesting to think to see how they're talking about and thinking about air quality issues back in the 1920s. And this was a kind of a fun little side project, or one of the little sub projects as part of this study. There was this hypothesis that was popular at the time, that the smelter that was down in Murray, there were several smelters kind of in the Murray area, so not directly in Salt Lake, but kind of a few miles away. Folks thought that the smelters were emitting sulfur dioxide, and the sulfur dioxide was creating a heavy blanket which prevents the smoke from rising. And of course, they didn't know about inversions at that time, and so that was kind of the popular hypothesis. And the person at the time, the scientist who was there, he's like, no, this is crazy. Gases are well mixed. But we want to be responsive to people's interests, and so let's see if we can design an experiment to show what's going on. And so the scientist, St. John Perot, government smoke expert, yesterday observed Salt Lake's smoke bank from an airplane. So he got some flasks and evacuated them and got in his biplane and flew up through the inversion layer and opened them up at different altitudes and brought it back and measured the sulfur dioxide and showed that the sulfur dioxide concentrations decreased as you got up higher, and just like he expected. There wasn't a thick layer of sulfur dioxide that was preventing mixing. And so, but I think it's interesting. It's also interesting because that's actually a similar attitude today. Most people, when you ask them, they blame factories for air pollution, when actually the biggest contributors are cars and homes. And factories are actually a much smaller source of particulate pollution today. One of the other tools they were using to monitor pollution was looking at these Ringelmann charts. And that's it's kind of like, it's a visual opacity sort of metric. So you look at a smokestack. So there's different examples over here on the right. And you would hold up this chart and try to judge the opacity of the smoke plume above the stack compared to the thickness of the lines in the chart. And that determined whether it was a number 1, number 2, number 3, 4, or 5. And each of those correspond to a 20%, roughly 20% increase in opacity. And that was one of the tools that they were using to try to understand, you know, who was emitting more pollution and who was emitting less. But the air quality was extremely bad. The sulfur dioxide they were measuring that winter in 1919 to 1920 was averaged around 150 parts per billion, which that's twice as high as today's ambient air quality standards of 75. And today, since we no longer have coal combustion in the valley, we typically see about 1 part per billion of sulfur dioxide. That they actually did measure total suspended particles. I actually don't know how they measured it, but they had something that measured it, and they were measuring 2.5 milligrams per meter cube, which, you know, that's a different unit. That would be equivalent to 2,500 micrograms per meter cubed. Of course, that's total suspended particles. It's not fine particulate matter, but that is chunky air. It is air that you can chew. And this last metric here, this is pulled out of the report. They just took glass jars and they set them out in different parts of the city and left them out there for the whole winter, and then came back and collected them and see how much kind of gunk fell in them from the air. And the units they're using are tons per square mile per year. And in the railroad and industrial parts of the city, they're measuring 1,000 tons per square mile per year. And in the residential parts of town, 300 tons per square mile per year. And so then they took this, you know, they took the jar of stuff and they dumped it out and they combusted it. And then they weighed it again to figure out how much of the solids they're measuring are from incomplete combustion. And it's around about, you know, 30 to 50% of what they're collecting is actually incomplete combustion. This actually points to kind of how they were thinking about it and how they were really trying to tackle this thing. If we could have more complete combustion, you know, boilers that are operating at a better temperature to extract the, you know, the heat that we need out of it, that could reduce our emissions by 50% or more. So after that kind of period in the 20s and the 30s, there was a period in the Great Depression, and interest in air quality, at least in the newspapers, really dropped off. But then it started to tick back up in the late 1930s. There was actually smoke monitoring was a job that was part of the New Deal. So there was a bunch of people would go up to the top of buildings and they would scan around the city with these Ringelmann charts, and they would look for smoke plumes that were very dense, and then they would get on the phone and, you know, let people know, like, hey, that place is not operating in their boiler at the right temperature or whatever. That was part of the New Deal. In the 40s, there was there was frequently periods of concerted effort to pass more stringent ordinances. And so here's an effort. In 1941, there was one of these pushes, and this is the Salt Lake Telegram. And I just think it's fascinating to look at this and, you know, see, this is, you know, the run up to World War II, Nazis taking over Bulgaria. But here, right on the front page, you know, smoke density charts indicate that the Salt Lake problem was never solved. And, you know, they have this time series of, you know, like 15 years of Ringelmann chart smoke density data that they're talking about the unrelenting black menace cloaking the city. And they also ran these things called Today's Smoke, which is kind of like the daily smoke forecast or the daily air quality forecast, which is very similar to what we see today in the Salt Lake Tribune, which is, you know, the air quality index that they publish every day. During World War II, there was, rightly a massive industrial mobilization to address World War II. And during that, the air quality became a secondary factor, and there was a lot of steel. There was some steel manufacturing in Utah, and so everything kind of ramped up. And this is an interesting data set that was collected. So when the Salt Lake City Airport was first established, you have to record visibility in order to inform the planes when they can and can't land. And so they tracked the number of hours with visibility of 3 miles or less due to smoke at the Salt Lake City Airport. These are 5-year moving averages during the winter time. And so you can see this, this increase in the density of smoke, of air pollution during the war years. And going into the 50s, this is when, as part of the airport in the 1950s, that's when regular weather balloon launches were started, and this is when the kind of the science of inversions was being established and worked on here. So this is, I think, one of those folks is Doug Dixon. And this is these are pictures from his master's thesis. And this is kind of the first effort to really understand inversions and understand the meteorological component of the air pollution challenge. And so it's fascinating to read through this master's thesis that really led to a more complete understanding of the reason why poor air quality exists along the Wasatch Front. This is also around the time when the London fog disaster happened, and a bunch of people died from that. And Genova, Pennsylvania, the inversion in Genova, Pennsylvania also happened around this time. And so inversions were starting to become an area of interest, in a lot of places, but certainly it was obviously very important here. In 1962, the state created the first major state-led report on air quality. It's actually a fascinating report. It's not that long. It's very concise, but it's really awesome. It summarized all the research that had been done up to the point. Some of the concern that they were talking about in the report and monitoring was related to nuclear fallout concerns because of the nuclear testing that was happening. But at the end of the report, they kind of came to the conclusion that there was a lack of continuous data, and new instruments were coming online now to be able to measure other air pollutants. And they decided, let's not do anything now as a state. Let's continue to collect more data, and we can take a look at that, and then we can take action. But around this time also, there was a lot of, across the country, there were air quality issues. And so some of the attention started to shift nationally, and also the air quality challenges in California started to dominate the national conversation. And that's when the Clean Air Act was first passed in 1963, and the Motor Vehicle Control Act of 1965 passed the first vehicle emission standards. And the reason why that was such an issue is because, going back to the energy plot, this is right when a lot of people were starting to drive, and petroleum use was really skyrocketing. And this is also a time when natural gas started coming into the Salt Lake Valley in 1930, and so natural gas becoming more widely available. And so coal was starting to decrease in terms of home fuel heating. And so really the focus then was really started to be on petroleum. And I found this really amazing editorial. It's the bountiful mayor looks to electric car. And this, in just the introduction to this is just, it kind of knocked me over when I read it, but it's the electric automobile for clean, quiet, efficient urban transportation is the subject of sharply increased interest these days as a means of combating air pollution, noise, and traffic congestion. And this is in 1966. This is an editorial from 1966. It's about the GM Electro-Ver. This is a prototype car that the GM was building. And the Electro-Ver, it could get up to speeds of up to 80 miles an hour and have a range of 100 miles. It's essentially a Nissan Leaf. The battery was very rudimentary and it didn't last very long, but it's essentially, in terms of functionality, it was a Nissan Leaf. Unfortunately, GM ended up mothballing that program, and then they brought back the EV1 around in the late 90s, and then destroyed all of those cars. That created a big controversy. You can go watch Who Killed the Electric Car. It's an interesting documentary about all of this. But it's interesting to see that even in Utah, the mayor was talking about it, which is just kind of a metric to understand, how people were thinking about it and how serious of an issue it was. In 1970, the Cleaner Act was amended and the EPA was created. I don't want you to focus on all of the details of this. The federal air quality standards were a lot less stringent in 1970 than they are now, because we know a lot more about air pollution now. But just look at this last column, the number of exceedances in 1970 for all of these different pollutants. Total suspended particles, sulfur dioxide, carbon monoxide, oxidants is ozone and nitrogen oxides. There was a lot of exceedances, and this is kind of the first modern analog metric that we have to kind of compare our modern atmosphere with what existed previously, and the air quality was terrible. It was really, really bad. Much worse than it is today. The very first PM 2.5 measurements that occurred in Utah were part of a pilot project that the EPA ran in the early 80s, testing new instruments that could measure smaller particles, because before that they were just measuring total suspended particles. And so somebody built these instruments that had a size selector part of it, and they deployed them in different cities for just a couple months at a time over a couple of years. But this is the very first data in Utah, PM 2.5 data in Utah. This winter of 81-82, you're seeing these measurements are once every 6th day. I think they're pretty laborious, and so they only did it essentially once a week or so. And so if you take the 35 micrograms per meter cubed, and these are 24-hour averages, if you took them, it's 5 or 6 exceedances during that winter, and so that's probably analogous to what our air quality was a decade ago. It's probably similar, a similar level. In the mid 80s, there's a really important case study in Utah that I'm sure many of you are aware of. The Genova Steel plant, there was a labor strike that shut the Genova Steel plant for a year, and this thing over on the right, the front page on the right, is the day after Geneva started back up. So the front page of the Daily Herald, Geneva belches back to life with plume of smoke. This was a really important deal. There were front page articles in the Daily Herald, once every couple of weeks about Geneva Steel. After it came back online throughout that winter of 87-88, there were basically constant letters to the editor nearly every day of people who were upset at Genova Steel and the pollution they were creating, and people defending Genova Steel, saying it's an important source of jobs and economic livelihood for our city and our state, and we can't let pollution, shut it down. But Dr. Arden Pope, he was an economics professor at the time, got started looking into that data and published, one of the first case studies, or published a case study that was just really useful. It's, this is the PM 2.5 level or PM 10 levels, and the winter before the steel mill shut down, and then the winter it shut down, or the year it shut down, and then the winter afterwards, the PM 10 went back up. And when you compare that to hospitalizations, they have the same pattern. And so it was a very clear signal that particulates were actually very serious and had very large impacts on health. And that was really surprising at the time, because at the time, a lot of the air quality was focused on carbon monoxide and oxidants, and ozone, and nitrogen oxides, and particles. People thought particles weren't really that big of a deal. And that's because the data they were looking at was total suspended particles, and a lot of larger particles, you get blocked by your nose. They don't get into your lungs. And so it was only once they started looking at the finer particles you realized, oh wow, this is actually a really important health impact. And this case study was really critical to opening a lot of people's eyes, and it really launched a huge area of research that is still going on today. Around the same time, Governor Bangerter commissioned got together a commission to address air quality. He ended up making 146 legislative and budget recommendations to address air quality. And it's interesting because many of those recommendations we're still working on today. It's, things like fuel swapping for people who use wood burning as their primary heat source. It's, more efficient emission controls on vehicles. It's addressing building emissions. It's all of those things. It's having better public transit. It's really interesting to see how many of these ideas actually came from 3 decades ago, and we're still trying to work on implementing them more completely. But at the beginning of this report, this Clean Air Commission actually took a step back and said Utah has 3 broad options. Our option 1 is we could just simply do nothing and let air pollution increase. This wouldn't cost the state anything, but of course, and it wouldn't require any changes in lifestyle. But this option would violate federal law, and lawsuits and sanctions can be expected. So they were like, well, maybe this isn't such a good idea. Option 2 is, Utah can kind of maintain the current or slightly reduced air pollution levels as mandated by the federal government. Essentially, Utah is not going to try to set our own destiny. We're just going to let EPA tell us what air quality we need, and we're only going to try to get to the federally mandated air pollution limits. And they thought, if to do that, we might need to address growth of our economy, and control emissions, or address major sources, or some combination of the two. We're going to have better monitoring and enforcement. And the end of this, it says, this option appears to be current policy by default, and that has been the current policy. That is still the current policy today. 30 years later, is to more or less just follow the federal air quality standards. But there is a third option, and it was really interesting to see this discussion here in 1990. It said, Utah could try to reduce pollutant levels far below the federal health standards. And in the long run, this would probably cost a lot less than either of the other two options, because you get other unquantified benefits because of better health and less direct costs to the consumer because you have better energy efficiency and things like that. And they thought, it's probably achievable if the state of Utah has the political will and creativity to accomplish it. And so, but then they started actually digging into what it would take to follow this option. They really wanted to dig into this and say, what's the viability of this? And whenever they started to dig into that third option, that would reduce pollution levels significantly below federal standards, they ran into economic, technical, and legal, and regulatory, and socioeconomic and political issues. And they said, compromise is necessary. And so, this gets back to the balancing of environmental stewardship and economic development, and trying to find that balance. They have an example that, carbon monoxide was a really big issue at that time, and so they said, theoretically, if we could, convert all gas cars to natural gas, that would help solve our carbon monoxide problem. But we don't control the manufacturers, we don't control the regulations, we don't. That would be uneconomic, and so they're just like, this is actually a really hard problem. We just don't have the technology, economically and technically viable solutions to implement to really achieve this goal. And this is where I get optimistic, because this is where today, this is the thing that has changed, is that we do have these options available to us. So some lessons learned, some takeaway messages. Utah has basically always had air pollution challenges since before it became a state. Also, our air quality is better today. It has improved through time, and it is likely better today than it has been probably since any time since the mid 1800s, which is actually kind of incredible. And it shows that history shows that environmental stewardship is compatible and probably essential for economic development. I can guarantee you, if our air quality was as bad as it was in 1970, today, you would not nearly have as many people living in Utah as we do. And so you need both of these things to go hand in hand. Our history has many lessons about what has worked and what hasn't. There's, for a long time, there was an effort to just like, hey, let's just monitor it. Let's not put regulations in place. Conversely, the regulatory approach from the EPA has made huge strides in Utah, as it has across the country. But we're likely going to get to a point where that tails off, because once we still haven't quite met federal air quality standards, but we're getting close. And if we ever do reach it, that's no longer going to be a stick to get us to pollution levels that are far below federal standards. And so there might need to be a change in paradigm to how we're thinking about air pollution and taking it out of a regulatory approach and thinking about it in terms of a stewardship or economic development approach in order to make further progress. And again, what makes me optimistic is that, for the first time in, 170 plus years, we have economically and technically viable solutions to really address these air quality challenges. Everything from clean energy, electric vehicles, net zero buildings, all of those things are getting more cost effective and getting more widely adopted. Utah also has a really unique opportunity to lead the country in terms of common sense bipartisan solutions. We're a business-friendly state that has a history of trying to balance the environmental stewardship and sustainable growth. And we have a booming tech sector, and they're highly motivated to address global challenges. And so it's an open question about whether we can effectively harness that and foster it. But there's a lot of reasons to be optimistic and hopeful. This is Governor Cox's One Utah roadmap that he put out when he came into office. And I just went through and highlighted all of the places where energy and environmental stewardship and sustainability factor into his vision of economic development in the state. And of course, there's a whole section on sustainable growth and taking action to combat poor air quality and climate change. And it just highlights that that it is part of the DNA. And there's always an open question about where is that balance? But there's the potential for addressing it. And Speaker Brad Wilson, he talks about how air pollution and clean air is not a partisan issue, and cuts across political lines in Utah. There is a fairly major proposal to address air pollution that will probably be announced sometime soon. I haven't seen if it's been announced yet, but it's an initiative called Prosperity 2030, reducing some emissions by 50% by 2030, and has different components. And so it's, this is a pretty ambitious program, and I wouldn't be surprised. I expect that it'll get pared back from its initial introduction, but it'll be interesting to see if how much of it gets in place, and the legislature hearing from people and saying that this is an important issue helps to get these kinds of things implemented. So that's all I have, and I think we have a few more minutes. I'm happy to stick around and answer questions.
Okay, thank you, Logan, for this really interesting talk. Let me start with a question by Steve Kruger through the chat, and he asks, my impression is that air quality has declined since the 1990s, both in winter and in summer. And then he asked whether this agrees with your data.
The air quality is better today than it was in 1990.
No, I think he's just arguing for the opposite.
Yeah, so I think that's actually not correct. I think I think it is better today. Pretty objectively, it's better today than it was in the 90s.
Okay, there's a question by Jim Steenberg. Great talk, Logan. Did you look at dust too?
There were a lot of conversations about dust. The biggest conversation about dust was actually in the 70s, when the metric for particulates was actually total suspended particles. You would get these really high readings. Some of it's from dust storms, but some of it's also from dirt roads. They had more dirt roads back then than we do now. And so dust was actually a big component of the total suspended particle measurement. And so there was a lot of concern in Utah about people who were saying like, hey, look, and at the time, people that then thought total suspended particles don't have a good correlation with health impacts. And so they thought, hey, this data, we're getting violations, but it doesn't really matter. And so there was a concern that Utah was going to get penalized because of the dust storms and the dirt roads in ways.
Okay, we have a lot of more questions. Sorry, we need to make this quick. This is going to last too long. So Noah Hirschhorn is asking, is there evidence that Prosperity 2030 is partially an effort to increase Utah's chance to host the 2030 Winter Olympics? Or is this likely a coincidence?
I think that's more of a coincidence. I think some of the language and the ideas of it came from the Utah roadmap that I was part of. It's separate from Governor Cox's One Utah roadmap. It's confusing, but there's just a lot of focus on this coming decade and having targets for this decade, and so that's where the 2030 deadline is. It is. The Olympics are always tossed in as a reasoning for why we should move forward, but it's not necessarily the reason for it.
Good. Tim Garrett asks, will winter air quality improve as climate warms if disappearance of surface snow cover leads to more ground solar absorption and reduced inversion strength under climate change, I guess?
That's a great topic for this department to address. I've been asked this before. My personal sense, and there's a lot more people who know more about this than I do, but my personal sense is it's going to be a competition between, yeah, there's less snow on the ground, and so we won't have as strong of inversions, but as the jet stream gets wavier, we might have periods of high pressure that allow pollution to build up. Maybe it won't be quite as bad as it has been, but we'll still get moderately to kind of bad air pollution for long periods. So I think it's an open question about how that will all play out.
Right. John Horrell asks, actually says, great talk. And then he asks, did you see some of the stuff related to the Project Mountain Valley Sunshine in the 80s? Sorry. Led by Nori Fukuda when Geneva Steel was concerned in Utah County. Are you familiar with that? Project Mountain Valley Sunshine.
I'm not, but there's a bunch of research that was happening all through this period. Essentially, after the 1970s, there was just a bunch of research money that was dumped into air quality, and a lot of it was done in Utah. And I feel like I was going back through and finding all of this. There's a ton of modeling papers, Lagrangian modeling papers from the 80s and 90s, and just like, wow, it's fantastic.
Zipser is commenting and asking, my first trip through Utah was in the early 1970s, and it was shocking to drive through Utah County with black smoke and visibility much less than a quarter or half a mile. Geneva Steel, question mark? Yeah,
that was certainly Geneva Steel was a big component of that. I mean, there were other industrial facilities as well, not just Geneva Steel, but and back then, you know, a lot of people would have been heating their homes with coal, and any you know, commercial establishment would have a coal boiler to heat their establishment. So
do we have any more questions? Actually, I have a little simple question. How did you actually find all these reports in the newspapers back in the 19th century? I mean, that must have been, I mean, you can impossibly go through all the newspaper reports, right? Is there a search engine or something? Or?
Yes, there is. And so this is actually what uncovered this whole project for me, is actually the digital newspaper archive at the University of Utah. And initially I started just looking, I just started searching for air pollution. And what was interesting about that is the term air pollution only goes back to the 1950s, 1960s. And it wasn't until I started looking at articles around then that I saw people talking about the air pollution and then the smoke. And I was like, oh, wait a second, there's this different term that I need to be searching for. And then once I figure out the right terms to search for, then it went all the way back to those early days. And it's a fantastic resource. And actually, if anybody is interested in this topic, I actually have a Google document that is like, you know, 20 or 30 pages long. That's just filled with links to newspaper articles. And I would be happy to share this with anyone who is interested. I'm not sharing it widely yet, so like you would have to email me, and I would just give you access to it. But I'm happy for anyone to take a look at this. And it takes a minute to load because it's I've got it organized by decade, and there's just like all of these newspapers, and it's kind of like my annotated bibliography for this whole project. But there is an astronomical amount of information And I feel like I've only touched, a third of what can be learned. And so, each one of these things, I've just been like keeping these links, and you can just go. And so this is the digital newspaper archive, and you can pull up, this is the Provo Daily Herald from 1978, and these are just great. And you can zoom in, and these are all text searchable. And so if anybody is interested in this, or if anybody is interested in organizing a class around this or a student project around it, I am happy to share all of this with anybody, because I feel like the more people working on it, the better. And I can't possibly do all this myself. So if anybody wants to have this, I'm happy to share it.
Okay, so at Zipsa is commenting, please make this material available. And Steve Kruger asked, do you plan to publish this very interesting study? And that will be the last question for today.
Yep, I'm working on a paper. I've kind of stalled out on it, but I just got in touch with a social scientist, and I'm bringing him on to help me kind of wrap it up. And he's helping me with the narrative, and because I'm not a historian, so I don't know how to describe the methodology of what I did. I collected a bunch of articles, and, but there's actually a methodology. There's methodology, and so I finally found the right person to help me, and I'm hoping we'll get the paper submitted in the next few weeks. Actually, I think that the paper was mostly done, but I just needed help to get it in a finished state. And so my goal is to get it wrapped up and publish it sometime pretty soon. And that paper is going to have links to most of this stuff, but there's so much more than you can fit in a paper that I at some point I'll make this Google Doc just publicly available. But anybody who wants it, I can send it to you now or whenever. But there's a lot of great information here.
Okay, good. So thank you very much again for this really nice and informative talk. And I hope to see all of you next week again for our next seminar. Thank you. Bye-bye.
Thank you, Logan. Bye-bye.
Yeah.
Can I ask a question real quick, Logan, if you still have a second?
Sure.
There's this massive smokestack out by the Saltaire, and I've heard two things about it, and I'm wondering if you have come across anything about it. And the first is that they built it so tall because they were trying to put the smoke above the inversion.
Mm-hmm.
And then I've also heard that the north side of the Oakers is so bare because of the pollution from that, and that it used to be more heavily forested.
So I don't know about the second point. The Oakers are kind of bare, but I guess you could go and look at the Stansbury Mountains and see if you could do a comparison. I feel like there's not that much on the north side of the Stansburys also. So I don't know about that, but certainly the height of that stack is intended to lift the pollution as high above, if possible, above the inversion, or even just releasing it high enough that those parcels of air can go up instead of going down, or even if they go down, if there's neutral buoyancy, you'll still just get a part of that plume, not the whole thing. So it's very much this plume stack is intended to distribute the pollution as high up as possible.
Okay, interesting. Thanks.
Okay, Logan, thank you again.
Yeah,
it was really cool. It was also nice to see the connections to our own department.
Yeah.
And the origins of that. It's really nice.
It's fascinating. It's really, and I had no idea. When I started this, I had no idea. I thought air quality was kind of, I knew about Arden Pope and the Geneva Steel stuff, but I had no idea that it was such a big deal back then. And then everything before that was just totally shocking to me. So.
Okay, and I'm glad you found the passcode. I'm just reading my email, so okay. Is it not part of the message? I think it should be when you get the invitation or the registration. They should send it about. It should be part of the link or whatever.
Yeah,
below.
it was, but it took a minute for that link to get emailed to me. So I
just
registered.
Yeah. Okay, it's always better to register before.
And-
Okay, there's still some chat. Let me see. Is it? Oh, okay. It's just great presentation. Thank you, and so on. Okay, no question. All right. Okay, we're gonna put that talk online. Is that okay?
Sure.
We do this with with all of our talks, but we put it online on YouTube. Actually, Holly Moreno is doing this, and so I hope
Okay.
this is okay with you.
Yep, definitely. I've given this presentation several times, and there are other versions of it online already. So that would be great.
Good. Thank you then.
Okay.
Bye bye.
See you. Bye.
Bye.